no big deal. So an introduction to the indefinite integral, super, super easy. It is this, okay? So if you want to know the antiderivative of x squared dx, okay? Can somebody tell me what the antiderivative of x squared is? X cubed over 3. Now, we said that that's 1, but this is 1 as well, right? And this is 1 as well. Right? Any constant on the end will create another antiderivative. Because when you take the derivative, you get x squared, x squared, x squared, because the constants just simply go away, correct? So therefore, what we have looked at so far is the definite integral. And the definite integral, like for example, we have an indefinite article in English and we have a definite article in English. A definite article in English is a. No. The. I won the award. That's a definite article. An indefinite article would be I won an award. So a or an is what we call an indefinite article, whereas the is definite article. So definite integral would be this. If you go 1 to 3, do we have a definitive result? Yeah, we're not figuring that out. You come up with like, 7/3 or something like that, right? Or we've been doing that the whole time. That's the definite integral. The indefinite integral is when you don't have any bounds. And it simply refers to the antiderivative. And in this case, we would say it's x cubed over 3 plus c, c being anybody want to guess? Constant. And that's the big idea that we have for today. We can verify that this is the antiderivative. How do we verify that this is the antiderivative? Just take the derivative of it. Very good. So we get to our notes. The definite integral. Integral from a to b of f of x dx. And we say that that is equal to large f of b minus large f of a. And that gives us an exact number. A definitive number that nobody disagrees with, correct? The indefinite integral, we would say, does not have any bounds. Integral of f of x dx. And we say that that is just big F of x, an antiderivative, plus a constant. Is there any question about the difference between these two? Big F is the antiderivative. The difference is in the definite integral, you take the antiderivative and you evaluate it at 2 spots because it's bounded. In the indefinite integral, you simply find the antiderivative and attach c to represent any constant. Sometimes I get people who try to be cute and they go c to the infinitieth power. So that's still a constant, isn't it? So, yeah, and then they divide it by pi and all sorts of stuff. So it's it's still a constant, right? Yeah. Okay, good. So first thing we're going to do, verify by differentiation that the formula is correct. This is saying that the integral or the antiderivative of negative x sine of x dx, which we don't know what that antiderivative is. That requires something that we call integration by parts. Have you guys started integration by parts yet? You did. Okay. So integration by parts is equal to x cosine of x minus sine of x plus c. And what we've learned is that what we want to do is we want to take this and take the derivative of it. And when we take the derivative, what should we get? Negative x sine of x. Okay, so that's what this means. Verify by differentiation that the formula is correct. It's kind of like this. 2x plus 3 is equal to 19. I subtract the 3. I get 2x is equal to 16. Divide by 2, x is 8. How do I check my answer? I plug it back in. So we're checking our answer. It's saying that the antiderivative of this is this. So if I take the derivative of this, I should get that. Okay, and that's be the first thing that you'll be expected to do on your test for this unit. So we have x cosine of x minus sine of x plus a constant, we are going to take the derivative of that. How do I take the derivative of x times the cosine of x? Product rule. What's the derivative of x? Times cosine of x. Plus x times, what's the derivative of cosine? Negative sine of x. What's the derivative of negative sine of x? Negative cosine of x. And what is the derivative of a constant? 0. Can I simplify this result? Cosine of x and negative cosine of x will cancel. I get a negative x sine of x. Right here. That came from the derivative of sine of x. So, this piece right here, x cosine of x, the derivative, we used the product rule, and we came up with this. Then we said, what's the derivative of negative sine of x? And we said negative cosine of x. And then we said, what's the derivative of c? And we got 0. So it's positive cosine of x. And this isn't times a negative. This is minus cosine of x. All clear? Okay, so you're going to be practicing finding derivatives. And it's important to practice finding derivatives because next week, you're going to be finding antiderivatives and derivatives at the same time. And that starts to confuse people a little bit. So we need to become really good at that. Yep, you verified it. You came up with what you started. You knew the final result. It was supposed to be right there. So that's why on the test, when I ask you to verify, you need to make sure that you show your work along the way, that I can follow it. Because some people just simply end up writing this and try to get points. You're laughing as though that's something that you would do. Is that something you would do? Okay, all right. Of course you would never do that because you're an excellent, excellent person. You'd never cheat the system like that. All right. So let's do the next one. This is saying that the antiderivative of the square root of ax plus b dx is 2 over 3a roots of ax plus b to the third plus c. Ick. In this situation, x is the variable. Dx tells us that x is the variable. All the others are simply constants. So we have 2 over 3a. And I'm going to change this. I'm going to write this as ax plus b to what power? Does anybody know to what power I write it to? 3/2 plus c. And I'm going to find the derivative of that. If I'm going to find that derivative, what rule do I need to use? The chain rule. So the chain rule will work out as follows. We have 2 over 3a times u to the 3/2 power. What is u? Ax plus b. Can somebody tell me the derivative of ax plus b? A. If the variables ever confuse you, rewrite it with numbers. If I said it was 2x plus 3, what's the derivative of 2x plus 3? 2. So therefore, the derivative of ax plus b is a. Okay, to find this derivative, I've dropped down the 3/2, correct? And when I do, what happens to the 2/3? So I get 1 over a times u to the 1/2. Now I multiply those together. 1 over a times ax plus b to the 1/2 power times a. What happens? The a's cancel, leaving you with the square root of ax plus b. Is that what I was supposed to come up with? It sure was. Then you know you did it incorrectly, or the rule is written incorrectly to begin with. So for example, if I said that the integral of 3x squared dx was equal to 5x cubed plus c, when you take the derivative, you would get 15x squared, right? Well, that's not that. So Either I made a mistake or the rule's written incorrectly. Which one would we say? We would say the rule's written incorrectly. Yep. So, you might, but that's easy to see, right? So, it's yeah. Okay. So, let's find the general indefinite integral now. Notice that the integrals don't have any bounds. So what would you do to find the antiderivative of x to the negative 3/7? Add 1, you get x to the 4/7 divided by 4/7. And dividing by 4/7 is the same as multiplying by 7/4. Plus c. I'm sorry, but if you don't write plus c on the test, I will mark a half a point off every time. Because it's an indefinite integral. You're right, but what this means is you plug in any constant here, and it could be, so by writing c here, you're saying it could be 9, it could be 8, it could be 3, it could be pi, it could be any of those. If you don't write c, you're saying it has to be 0, and that's not true. Uh-oh. Should I take the antiderivative of 2x and then the antiderivative of the inside? No, I can't do that. I got to do the integral of 2x minus 6x squared plus 10x to the 6th dx. Now I take the antiderivative, which is, what's the antiderivative of 2x? X squared. Minus, what's the antiderivative of 6x squared? 2x cubed. Whoop. Sorry, 2x is 6. What is the antiderivative of 2x is 6? 2x is 7th over 7 plus a constant. How about letter C? Yep, I got to multiply it out first. 2 plus g, 3g squared, dg. It's kind of fun. Antiderivative of 2? 2g, very good. Antiderivative of g? Antiderivative of 3g squared. Plus a constant. I'll mark points off. I'll show you the test from last year. Antiderivative of 2 sine of theta. Negative 2 cosine of theta. Good. Antiderivative of 4 cosine of theta. Plus 4 sine of theta. Nice. Flip it over. Two more and we'll be done for the day. Then we're going to sing happy birthday to D. Weiland. Yeah. What about E? Okay, Chris sees that there's a trig identity. What's the capital of the United States of America? And therefore, sine squared plus cosine squared is? So that means that sine squared minus 1 is the same as Not cosine squared, but negative cosine squared. So this becomes 3 over negative 3 over negative cosine squared of x dx. My good friend Cole Inderly just spoke up and said, well, I know what 3 over negative cosine squared is. That would be negative 3 secant squared of x dx. And Cole is very excited about secant squared because he knows that what do you take the derivative of to get secant squared? You take the derivative tangent, so we have negative 3 tangent of x plus a constant. Do you have an appreciation at this moment a little bit that finding antiderivatives could be a little bit more challenging than finding derivatives? In fact, I could change this pretty quick by just doing 3x, and all of a sudden, this becomes exceedingly difficult to find. Yeah, that would do it as well. My point is that minute changes, if we change it to 3x, could we find that derivative? Yeah, sure. You change it however you want. Finding the derivative isn't that bad. But finding the antiderivative all of a sudden starts to fall apart. Last one. Let's see what you really know now. Okay, Katie sees that I don't want a 2x. I just want x. Double angle formula. Wouldn't it be nice if your teacher gave that to you? These are formulas that I think are important for you to know. These are formulas that we see come up on the AP exam. Without a doubt, you need to know that sine squared plus cosine squared is 1. That's an absolute must, folks. 1 plus tangent squared is secant squared. That's an absolute must. Sine of 2x equal to 2 sine of x cosine of x. That's an absolute must. Okay? Those three, you better believe that I will expect that you can know those three. And I know you can memorize. I've seen you study for Haney tests. Okay? All right. So let's take that and let's put it to use then within our problem. And the problem says then I have 3, and instead of sine of 2x, what can I write in its place? 2 sine of x cosine of x. So then what happens? Yeah, this becomes the integral of 6 sine of x dx. What's the antiderivative of 6 sine of x? Not too bad, huh? Agree that that's all multiplication? So multiplication is commutative. So I should be able to write this as, 6 times sine of x times cosine of x over cosine of x dx. And that should be able to be rewritten as cosine of x over cosine of x times 6 sine of x over 1 times dx. That those are equivalent statements, right? So now, on. Your assignment is lengthy, but you're going to have time to work on it. We are also running out of time in this class, as we've had many days without school. So I'm going to get you your work, but you are not ready to do all of the problems in the assignment. We will spend, for sure, one more day. So I plan on spending Tuesday on this, but I would like to move forward then after that point. So I believe you will not get a new assignment Tuesday, but you will on Wednesday. So I want to be clear that if you decide to procrastinate on something, okay, because this weekend you have time to work on this assignment, that would be in your best interest, okay? All right, so very good.